Hello virtual learners, I'm going to be making a video for my 4th graders today. This might work for quite a few of your 5th graders, especially if you teach Common Core. I know that Common Core does decimals to the thousandths place. In Virginia, we do decimals to the thousandths place in 4th grade and then again in 5th grade. So the point of this lesson is we want students to be able to identify decimals that are expressed through the thousandths using base 10 manipulatives and or pictorial representations. So this is the aligning SOL for Virginia. It falls under the students will read, write, represent, and identify decimals expressed through the thousandths. I teach in Virginia Beach as a math coach, so there's my aligning VBO. Just some tips as you're practicing this. You want to make sure that you are changing up that whole. Students have worked with base 10 blocks for many years before they get to 4th grade, and often they develop a misconception that this is always 1, so this is always 10. And when we go to 4th grade and we start looking at decimals, this is not always 1 anymore. So we want to give them a lot of experiences with different size 1 whole so that they can really build on and use that 10-to-1 relationship to determine the value of different base 10 models. When you're doing this, I try to make it a game with my kids. I call them like base 10 riddles, and I start off kind of easy and then I get more challenging. So I would recommend that you practice graduated difficulty in that way. And this is just a tip from me. You're not required to do this, but I do this because I feel like it clears up a lot of misconceptions and helps students connect fractions and decimals. I do ask students to write decimals multiple ways as well as the equivalent fraction for the decimal so that they understand the decimals and fractions. Any decimal can be represented as a fraction and any fraction can be represented as a decimal. All right, so let's take a look at our first riddle. We're using these base 10 materials here. My flats are brown because that's just what I grabbed before school was out, but we're going to work with it. So first thing that's important to do is you want to tell the students straight up what's going to represent 1 whole. So they're used to this piece representing 1 whole, okay? And so when we draw a picture of this piece, we do not draw a square because the square represents this flat. So I'm going to say if this is how we quick draw that piece, is 1 whole, then let's take a look at our first puzzle. So first things first, if I'm looking at this, I have to find this here. So I notice that the 1 whole is smaller than this piece. So this piece must be greater than 1 whole. And I'm also noticing that this fits into this piece 10 times. So that is 10 ones. Or 1 plus 1 plus 1, all 10 times. So that means if this piece is 1 whole, then this piece must represent 10. If I were to write 10 as a decimal, and I can even do my picture, so that piece would represent 10. Or I could say 10 as a decimal, okay? All right, now watch what happens. This is where kids really get tricked up, okay? So now I'm going to change this. Now I'm going to say that this piece represents 1 whole. And now I'm going to want the value of the little piece. Uh-oh, she's trying to blow my mind. All right, so this long represents 1. That's a representation of a long, not 1. Then I need to figure out what is the value of this piece. So what I just noticed is this piece is actually smaller than 1. So when I'm writing my number representation for this model, I need to be thinking about how I can represent a number that is smaller than 1. There are numbers that are smaller than 1, and we can represent numbers that are smaller than 1 by using fractions and decimals. So now I'm thinking if this is 1 whole, this can actually fit into 1 whole how many times? 10. So this is 1 piece or 1 part out of 10 equal parts that make that whole, right? So it's 1 out of 10 parts that make the whole. Wouldn't that be 1? Ooh, that's not cute. 1/10. And then if that is 1/10, then when I go to write that as a decimal, I need to make sure that the 1 is in the 10ths place. So that is the 1's place. I don't have a whole right now, so 0 wholes. and 1 goes in the 10th place. When I was talking about having students write 1/10 different ways, I say as long as your 1 is in the 10th place, this is also 1/10. Even if you didn't have that 0 up front, this is also 1/10. This is also 1/10 because that 1 is in the 10th place. So if this piece is 1 whole, then this piece would represent 1/10. You want to try a different one? Let's try to change that whole up again, okay? I'm going to go back to this guy because that's what they're used to representing as 1 whole. I'm going to go back to that single unit, okay? So if that single unit is 1 whole, then what does this piece represent? So this piece is more than that piece, and I'm thinking, gotta change this. So now this is back to 1. So this piece is more, right? How many of the 1 wholes fit in this flat? And many students will remember there's 100 of these because students will call these hundreds even though they don't always represent 100. So if this piece is 1 whole, then this piece represents 100. Okay? All right, now I'm going to try to blow your minds, guys. Here we go. Now I'm going to tell you that that flat represents 1 whole. So if the flat represents 1 whole, can this be 100? It can't, because 100 of this would mean I would need 100 flats, right? This is smaller than 1 whole. I need to think about the relationship between these pieces here. How many of this size piece fits into this flat? Remember, we already know it's 100, right? But this is smaller. It's 1 piece out of 100 pieces that make 1 whole. 1 out of 100. If I write that as a fraction, that's 1 out of 100. We say that's 1/100th. If I write that as a decimal, I need to make sure that my 1 is in the 100ths place. So no tenths, and then 1 in the 100ths place. I could also write 100th like that because the 1 is still in the 100th place. That's still 100th. As long as that 1 is in the 100th place, you got 100th. Okay, we got that. All right, let's try another one. Okay, I'm actually going to keep this guy as 1 whole, but I'm going to ask for this piece for my riddle, okay? So now, that flat is going to represent 1 whole. So now I want to know the value of this piece. Now this piece is less than 1 whole, right? How many of this size piece fits in to 1 whole? This piece would fit into this piece 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. That means this is 1/10 of the whole. So I can write that as a fraction, or I can write that as a decimal, 1/10. Or remember, this is also 1/10, or this is 1/10, as long as that 1 is in the 10th place. Okay? All right. If this, oh, I'm going to trick you all up again. I'm telling you guys, this is where kids, they start getting their minds blown. You really want to make sure that they get a lot of practice with this. Okay? So now the flat is no longer 1. I'm going to make the long 1. So if that long is 1, then what does the flat represent? Okay, now that's 1 whole. This is more than 1 whole. How many 1 wholes fit inside of this flat? There's 10 of them, right? So if that's 1 whole, then this would represent 10 wholes. Yes, yes. All right, let's do a couple more easy ones, and then we'll try to do a little more challenging ones, okay? All right, let's do, I'll keep this flat as 1 whole. Now I got this cube here. Okay. So my flat represents 1, then what would this cube represent? Now, students have had a lot of experiences working with base 10 blocks before they get to 4th grade. They can see that this is more than 1 whole. If students don't understand this piece, you want them to stack 10 flats on top of each other so that they understand that this is 10 levels of flats. One of the misconceptions that I see with students who don't use manipulatives enough is that they think that there's 6 of those in here because they assume that the inside is hollow and that each of these flats is a face. So you do want to make sure that as they're building this up, they understand that there's 10 levels of that in here. Okay, so now this is not 100 anymore. This is 1. How many of this make this? And if I stack them up, this is 1 whole, right? 1 whole, 2 holes, 3 holes, 4 holes, 5, 6, 7, 8, 9, 10, and that makes the cube. It's not perfectly straight, but I'm recording with one hand, so. All right, so if this is 1 hole, then this piece must represent 10 holes, right? So this piece represents 10. Now watch what happens when I flip it. You gotta flip your brain when I flip my pieces. So now the flat is not 1 hole. I'm using that large cube as a whole. Now if that large cube is a whole, then what is the flat? It can't be 10 because it's smaller than 1 whole. But I do know that 10 of these fit into that because I just did it, right? So then this is just 1 piece out of 10 pieces that make 1 whole. So 1 out of 10, that's 1/10, right? Remember, this 1/10, we've already done 1/10 and it wasn't with these pieces. And that's good because we want them to understand that a 10th means that it's 1 out of 10 parts that make the whole. So this would be 1/10. Okay? Now you could even start doing things like this where you say, okay, well if that's 1 whole, then now what is this? Now I don't just have 1/10. Now I have 1/10 plus 1/10 plus 1/10, right? That would be 3/10, right? Or I could say 1/10 plus 1/10 plus 1/10 is 3/10. So I can change this to match what I got going on. Make sense? Okay, now I'm going to keep that large cube being my 1 whole. I'll pull a couple more pieces with it. So let's come back to this long guy. If this is 1 whole, then what is this piece? Ooh, that's a tricky one. It's less than 1 whole, right? So I need to think about this relationship here. How many of these make this? Well, remember, I can think about this piece in chunks. Remember how 10 of these made the flat? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 of them in each level, and then there's 10 levels of flats that make this, then isn't that 10 groups of 10 of these that make this? 10 groups of 10, that's 100. So this must be 1 out of 100, or 100th. So my 1 is going to go in the 100ths place. I've already done 100th with the unit and the flat, but now I'm doing 100th with the cube and a long. See how that works? So if this is 100th, let's just try another one with that same piece. All right. So if you had more than just 1 piece, you got to think about what's the value of the single piece first. So if this is one whole, I know this piece fits into this hole 100 times. So this is 100th, and that means all of these are also 100th. So how many hundredths do I have here? I got 1, 2, 3, 4, 5, 6 hundredths, right? So this model would represent 6 hundredths. If I wanted to write that as decimals, 100th plus 100th plus 100th plus 100th, 4 plus 100th, 5 plus 100th equals 0 wholes and 6 hundredths. As long as your 6 is in the hundredths place, you got 6 hundredths. You could also have it without that 0 in the front. That's still 6 hundredths because the 6 is in the hundredths place. This is still 6 hundredths because the 6 is in the hundredths place. This would still be 6 hundredths because the 6 is in the hundredths place. Make sense? All right, try one more, and then we're going to try a couple challenge ones. I'm going to keep that cube being one whole, and I just want to know what's the value of this piece now. Now I know it can't be more than one whole. How many of this little piece makes this piece? Well, that's 1,000, right? Because it's 100 on each level, and it's 10 levels. So 10 times 100 is 1,000. So that would mean this piece would represent, that doesn't look like a comma. This piece would represent 1,000th of the whole, right? If I wanted to write 1,000th as a decimal, I need to make sure that the 1 goes in the thousandths place. That's the ones place, tenths, hundredths, thousandths. So that would be 1,000th. If I had, say, 4 of them, that's 4 thousandths, right? So then this would be 4 thousandths, and this would be 4 thousandths. Does that make sense? Okay. I'm telling you guys, I'd mix this up. I really mix it up to make them think about their base 10 relationship here. Something that you might see that might blow their minds. So I say, okay, well, if this is one whole, let's do a challenging one now. Then what is this? Okay, let's try this one. All right, so if this is one whole, then this represents one whole as well, right? It's not 1,000 because I just told you that this represents 1, right? So this is 1, and now look, I have 3 flats. First, I need to figure out what's the value of 1 flat. I need to use this whole to do that. So this 1 flat, 10 of them make the whole. So this 1 flat is 1/10 of the whole. 1/10 plus 1/10 plus 1/10 would be 3/10. So I'm going to put a 3 in the tenths place. Now I don't have any hundredths on this model. If I did, these would be hundredths of this whole, but I left them out on purpose. So since I don't have any hundredths, I need a digit in the hundredths place that shows that I don't have any hundredths. And that 0 would be my digit in the hundredths place. And then over here, I got to think about the value of each of these pieces. This is 1 piece out of 1,000 pieces that make the whole. And I have 2 1,000ths here, 2 thousandths. So I need a 2 in the thousandths place. So this model here would represent 1 and 302 thousandths, okay? I'm going to keep that same model, but I'm going to change the whole, okay? So instead of this cube being the whole, I'm going to make the flat a whole. Now I got to change my thinking because I changed my whole, right? This one's tricky. But you know what? The tricky stuff grows your brain. All right, let's think about this. If this is one whole, does this piece represent more or less than one whole? It's going to be more because it's bigger, right? How many of this size piece make this? Well, there's 10 one wholes in this, right? So this is 10. And if this is 1, then this would be 1 plus 1 plus 1, which is 3, right? If this is 1, each of these pieces is 1 out of 100 or 100th, right? And I have 2 of them. So plus 100th, I've got to put the 1 in the 100th place, right? Plus another 100th. Oh, that's 200ths. I don't have to write that out like that. Now, if I do want to write it out like that, if that helps me think about it, I'm definitely going to do that, okay? All right, now when I put these together, 10 and 3, that's 13 wholes. And 2 hundredths of a whole. 13 and 2 hundredths. See? So I did some easier ones and I did some challenge ones. I do have some activities that I have made to practice these if you want some more practice, because this is definitely something that takes a little bit of practice. You have to understand what your whole is, and you have to understand how many pieces will make another piece, and you have to be able to use that base 10 relationship to understand fractions and decimals. Now, if I was to write 13 and 2 hundredths as a fraction, because I like to write them both ways, 13 and 2 hundredths. There you go. All right, well, if you need any more practice, just message me. I can send you some more resources, and happy practicing.